our little algebra series, this is the third, we're going to look at the commutative property and how that affects rearranging or simplifying. Now the commutative property simply implies that order is not important. So with addition, we know that 2 plus 3 is going to be equal to 3 plus 2. In both cases, they're equal to 5. And similarly with 2 times 3, we know that's 3 times 2. It doesn't really matter what numbers we put in there, as long as if we reverse them, they will give the same answer. So that works with algebra as well. So if we have x plus y, it's going to give the same answer as y plus x. And if we have x times y, it's going to give the same answer as y times x. With addition and multiplication, they're both commutative, order is not important. And we can use this to simplify expressions. So if we have 2x times 5y, we can shift the order around so that we have 2 times 5 times x times y rather than 2 times x times 5 times y. And then we can do 2 times 5 is 10 and xy, remove all the multiplication symbols because it's algebra, and we get left with 10xy. So the first step, expanding this part here, once we know what we're doing, we can skip it and go straight from here to here. 2 times 5 is 10 times x times y. Easy peasy. Now, the second convention we have to look at is that when we write out an expression, especially with expressions that have been multiplied, we tend to write them in the coefficient first and then in alphabetical order. So here we have a term x10y. It's not strictly wrong, it just means x times 10 times y, but it doesn't follow the normal convention, so let's do that. Let's put the 10 out the front and x times y, and we can do that because of the commutative property of multiplication. Here's another case. We have 7 plus 2x plus 5. We want to add the constants together, so we just swap these two around because we can, because addition is commutative. 7 plus 5 is 12 plus 2x. Done. Now the other thing we should note is that when we're simplifying the expression, so in this case we're simplifying this expression, we should put the equals in a line, and anytime that we do an operation, we create a new line of working. So in our first line of working, we wanted to move the 5, so we wrote that out. And in our second line of working, we wanted to add these two together, and we wrote the answer underneath. We don't tend to go equals, 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 equals across the page. We tend to go down the page. Makes for a story. I started with this, then I did this, then I did this, then I did this. Okay, so that's multiplication and addition. That's quite easy. Subtraction, though, is not commutative. Order is important. But we can use a property of subtraction to help us simplify algebraic expressions. So here's a case that we can look at. 2 take 3 is -1. That's not the same as 3 take 2, which is +1. Similarly, if we use algebra, x take y does not equal y take x. And something similar occurs for division, but we'll work on that later. Now, if we did want to rearrange an equation that had subtraction, what we need to do is consider the following. If we have an expression in arithmetic, -3 plus 2, this plus indicates that we can change the order, which is excellent. Now, when we change the order, we end up with 2 plus -3 with a bracket around it. Now, we can do a special operation on our operators. X plus negative, if we have a plus x, if we have a positive and a negative together, the answer is always negative. So we can change that into a subtraction symbol. So plus minus becomes subtract, 2 minus 3 becomes -1. And that makes sense. If we add 2 to -3, it will get us to -1. Now, similarly with a larger expression, we have 7 plus 2x take 5. Instead of going from plus minus to minus, we're going to go from minus to plus minus. And we're going to do that so that we can manipulate or rearrange our equation. So here's our case, 7 plus 2x minus 5. We want this -5 to go over here. So what we're going to do is we're going to change this minus into plus minus. So instead of subtracting 5, we're going to add -5. And here it is here, adding -5. Now that we've got an addition operator, we can change the order. So we're going to swap these two over. And you can see the 2's gone to the back, and the -5 is here. Now once it's here, we've got a plus minus together. Oh, look at that, we can change it back to minus again. So we can go 7 minus 5 is 2 plus 2x. Finished. Now once we understand this concept, there's no real need to do this plus minus stuff anymore. It's just to understand what's going on. All you have to remember is to keep the leading sign with the term. So if we wanted to move the minus 5, if we want to move the 5, keep the minus with it and move both the minus 5 and the 5. So moves the minus and the 5. So we're going to move both of these. So we moved it from here to in there, and that would look like this. And then, like before, we can do 7 minus 5 is 2 plus 2x. These are really powerful ideas in algebra and things that we need to get good at. So here's a couple of cases where we could use it. Always like to go back to modeling cases, because at the end of the day, that's what we use algebra for most, is showing how to find an answer. So the temperature was 26 degrees. It became colder overnight. We don't know how much colder, so there's our unknown. It rose 20 degrees the next day and then halved by the next morning. So started at 26 degrees, went down something, and then went up 20 and then halved. So we've got 26 take x plus 20 in the numerator. In that term, what we want to do is simplify it. So we're going to move this 20 over to here and then add it together. We can do that by swapping the minus x to the back and putting the 20 in its place, which is what we did here. And that would then simplify to 46 minus x on 2. Now if we have a case where the temperature was 20 degrees, we could substitute that into x, and we would find out that the temperature is 13 degrees, or that's how much it dropped, I should say, on that first night, which is what the unknown is. Similarly, for a dress that was made and sold originally for 20% profit and then discounted for 5%, we can show that. Let C equal the cost of the dress. Let F be the sale price. So here's the cost. Here's increasing it by 20%. Hopefully you've done a bit of this in your primary class. Here's it being decreased by 5%. 1 plus 0.2 becomes 1.2. 1 take 0.5 becomes 0.95. We multiply those together with our calculator. We get 1.14 times the cost of the dress will be the final price. Now we know, if we know the cost of the dress was $50 to make, we substitute in 50, we get 1.14 times 50, which is $57. And from that, we now know that if the original dress was $50 and the final price was $57, they made $7 profit on the sale, and the dress sale price was $57 in fact. So there you go, a bit of rearranging and simplifying algebraic expressions, and we're going to be doing lots of this, so this is just a little bit of an introduction. Hopefully that's okay, and I'll see you in the next one. Thanks everyone.